Welcome back, grade 8 students. For today's science lesson, we're going to be learning about heat and temperature. So the question we're about to answer is, what is heat? So heat is a form of energy because it can move things, right? So how can you say that it can move things? For example, it makes a hot air balloon rise, doesn't it? And it also makes steam engine move. Now, heat is also measured in joules, capital J if you're going to use it in formulas. So heat can be converted to other forms of energy, right? A good example of it is photosynthesis, which plants always do, right? They convert sunlight into their food. So heat is then converted to chemical energy. Oil and gas are also burned in power stations to produce heat energy, right? The heat energy they produce is then used to turn the turbines, which then produce electricity, okay? Which is electrical energy. So how is heat produced? So in basic terminology, heat is produced if a particle moves around very, very quickly, right? So the faster the molecule or the particle move, the hotter it gets. So as the particles also heat up, or as the particles move around more quickly, it also tends to take up more room, which is why if you see some objects heat up, they also expand and they bloat, right? They get bigger. Okay. It is also why substances change forms when heated. For example, ice turns into water again, and then water will eventually turn into water vapor. Heat transfer. Heat always moves from a warmer place to a cooler place. Always, right? So if you put a hot object in a cool room, that hot object will come to room temperature. For example, you just, brewed yourself a coffee, place it on your table, leave it there for a few minutes, and it will eventually reach room temperature. And vice versa, if you have an ice cream, put it on your desk, in a few minutes, that ice cream will become liquid, right? So we have three types of heat transfer. We have conduction, convection, and radiation. So how does the heat of the sun, right, get to Earth? It's a mystery, right? It's a great big mystery. There are no particles between the sun and the earth, so it must travel by radiation, right? hmm So, radiation is just the transfer of heat in rays from a hot object without needing a medium to pass through. So, in this example that we have over here, right, it says here that there are no particles between the sun and the earth, so it must be radiation, right? Because there's almost no other way that heat can be transferred without a medium. Radiation is the only way. So, radiation also travels in all directions from a hot object. The hotter an object is, the more heat it will radiate out. Okay? Now we have a question here. Does the surface affect the way heat is radiated? Well, I get to answer that later on. So here's some question about radiation. Why are houses painted white in hot countries? Why are shiny foil blankets wrapped around a marathon runner at the end of a race? To answer the first question, white reflects heat radiation and keeps the house cooler. So, houses tend not to be colored black or darker colors because those tend to soak or absorb heat more than the lighter colors would. For the second question, the answer is the shiny metal reflects the heat radiation from the runner's back, right? And it stops the runner from getting cold. right? The next type of heat transfer is conduction. So what is conduction? Conduction is just the transfer of heat through a solid, right? By being passed from one particle to the next. Particles at the warmer end moves faster, and this then causes the next particle to move faster, and so on and so forth, right? So in this way, in an object travels heat in an object travels from the hot end to the cold end. Okay, when you heat a metal strip at one end, the heat travels to the other end. Right? Have you ever tried that? Just grab a spoon and put the tip of the spoon near any source of heat, right? And eventually you will feel the heat near where you're grabbing the spoon. Even if you're grabbing at the very tip of the spoon, you'll eventually feel heat there, right? Because metal tend to be a great conductor of heat, or most of the metals are great conductors of heat, meaning that they can transfer heat faster than most objects. As you heat the metal, the particles vibrate. These vibrations make the adjacent particles vibrate, and so on and so on. So the vibrations are passed along the metal, and so is the heat, right? So as we explained earlier, heat is just formed when particles move around very quickly. So this vibration, as the vibration gets faster and faster, it will cause the other particles to vibrate as well, and it will cause the object to heat up. Okay, so we call that conduction. Okay, now if a substance easily allows heat to move through it, we can say it's a good conductor of heat. For example, as I said earlier, most metals are good conductors, right? So if then a substance does not allow heat to pass through easily, we can say that it is an insulator, right? Examples are, or the best example we have is plastic. Okay? So why do many saucepans have plastic handles? Exactly, right? So saucepans have plastic handles because plastics are good insulators, right? They don't easily allow heat to be transferred. So that means you can hold on to that pan for a longer period of time without feeling the very hot temperature of the metal pan itself. Conduction versus insulation. Here we have two pictures, right? On the top picture that we have here, we see the hand, all right, grabbing an insulator, which then has a pipe of conductor, all right, that is directly on top of heat. Okay, so we can see here that basically the hand will not feel the heat from the conductor right away because it has an insulator, right? Unlike the picture we have here in the bottom, where the hand is directly touching the metal, we can say that it's a metal stick, right? Which means that he'll immediately feel the metal stick getting hotter and hotter in his hands, right? The top picture will not because it has an insulator. Here we have a few questions or a few things that we should clarify. So which of these items here are conductors and which of these items here are insulators? So let's answer them one by one. For the first one, it's already been in the example a while ago. So wood is a natural insulator, okay? It is a natural insulator due to the air pockets within its cellular structure, which means that it is 15 times better than masonry, 400 times better than steel, and 1,770 times better than aluminum, right? Now, aluminum is metal, so it conducts heat very well. As I have mentioned before, most metals tend to conduct heat very, very well. How about plastic? Plastics are excellent insulators, meaning that they efficiently trap heat. Okay? That is the advantage in something such as a coffee cup sleeve, right? That's why you see plastics are usually wrapped around a coffee cup. How about glass? Glass is also an insulator. It doesn't allow the flow of electrons easily from atom to atom. Okay? So, glass is also a insulator. Now, how about iron? Again, iron is metal. Okay? So the electrons involved in metallic bond of iron are free moving, causing it to be a good conductor. How about polystyrene? I can't pronounce that, but the other name for that is styrofoam. So styrofoam is a good insulator because the plastic foam contains billions of trapped gas bubbles. How about copper? We've explained it a few times already. Copper is also metal, meaning it's a very good conductor of heat. How about cardboard then? Cardboard is actually a very good insulator. It traps air in little pockets inside it. Okay? So we can now move on. How about convection then? What happens to the particles in a liquid or a gas when you heat them up? Okay? So the particles spread out and become less dense. A liquid or gas, okay? So it is the way in which particles in the gas or liquid move upwards carrying the heat with them. Okay? So yeah, as you can read over here, think about when you boil water, the bubbles move upwards, right? It doesn't move downwards, it moves upward. Or think when a gas heater in the room, the heat rises around the room. So it doesn't stay in the bottom, it always stays on top. Okay? So we can say that, uh, okay? As you can see here, here's a very good example. Heat always rises, right? So this is the cooling compartment that we have over here. It is warmer in the bottom, so I mean, it is warmer in the bottom. So this warmer air rises and a convection current is set up. Okay? That is why the cooling compartment is always on top. Okay? Because the hot air below rises up, and then due to the cooling compartment, it will then cool down, and then it will sink back down. Okay? So should a radiator be called a radiator? That's a question for you to answer. So here's some convection questions. Why does hot air rise and cold air sink? Cold air is more dense than warm air. So the cool air falls through the warm air. As I have explained earlier, right? The particles become more spread out and becomes less dense if they're heated up. That's especially true for gas particles and liquid particles. That's why cool air is more dense. So why are boilers placed beneath hot water tanks in people's home? Because hot water rises. So when the water boiler heats the water and the hot water rises, the water tank is filled with hot water. Right? It's similar concept to what we said about the hot air. So here we have heat versus temperature. So what is heat again? Heat is just another form of energy, right? While temperature is not. It tells us how hot an object is, okay? It is measured in degrees Celsius, okay? So again, heat is measured via joules and temperature is measured via degrees Celsius. Okay, so it's completely two different things. It is not the same as heat energy, although the two quantities are related. Okay, for example, a beaker of water at 60 degrees Celsius is hotter than a bath of water at 40 degrees Celsius, but the bath contains more joules of heat energy. Why is that? Because beaker of water is just a small container, bath of water is a large container, meaning that it has more heat energy in it. So if an object has become hotter, it means it has gained heat energy, right? If an object cools down, it means it has lost its heat energy. Simple as that. So heat energy always moves from hot object to cooler objects. For example, a cup of water at 20 degrees Celsius in a room at 30 degrees Celsius gains heat energy and heats up. Its temperature rises, right? So as I have discussed earlier as well, if you have a cup of tea in a room which is room temperature, right? That warm tea or that hot tea will eventually reach room temperature. So a cup of water at 20 degrees Celsius in a room of 10 degrees Celsius loses heat energy and cools down. Its temperature will fall, right? I think we have discussed this earlier. Ta-da! Now we need to discuss about expansion and contraction. So why are gaps left in pavement, railways, tracks, and floorboards? Okay, why are electricity cables left slack? Why are bottles of minerals not filled up to the top? Because materials expand when they heat up and they need to leave room for that. As I have explained a lot earlier, right? As the objects or as the particles move more quickly, they tend to use up more space, meaning that objects will tend to expand as they get hotter and hotter. So that is why you see gaps in the pavements, right? Those bricks, even though you don't see them, expands little bit. Expansion versus contraction. The reason materials expand when heated is because the heat gives the molecules energy, and as a result, they begin to move, leaving them further apart, and hence the materials expand. Cooling has the opposite effect. The particles move closer together, causing the molecules to contract. So, heating up, as I explained earlier, makes molecules less dense, right? Meaning that they move away from each other because they're going to be moving and moving. Um, while when cooling an object, right, they tend to get closer to each other and they become more dense. Okay, one exception of this is water expands when cooled. Right, that's it for today, guys. Uh, See you in your lesson for tomorrow, grade 8 students.